My name is Palma.
My name is Sujata. My name is William. My name is Jowai.
And we are the member of Group of Class 9. The theme of today's exhibition is to verification of Archimedes principle, and our aim today is to verify Archimedes principle. And the material required to do this experiment is an overflow can, graduated beaker, metallic circular block, and a spring balance. So let's move on from theory. When a metallic block is immersed into water below the surface of water, four vertical forces act on the block. These forces can be grouped into two, and they can be grouped into downward forces and upward forces. The downward forces is the weight of the block, and the downward thrust due to pressure of the liquid in the top surface of the block. And the upward forces is tension of the spring, which measures the apparent weight, and the upward thrust due to liquid on the lower surface of the block. The upward force is also known as buoyancy. So the second point is when a body is partly or completely immersed into water, then loss in weight of the body is equal to the weight of water displaced by the body. It is also equal to the buoyant force or thrust exerted by water on the body. Why? Because the weight of the body is less when it is completely immersed into water. It means that loss in weight of the body goes on increasing as it is immersed more and more into the water. So
Archimedes principle, it was first of all observed of Archimedes that body is less in weight when immersed into water. And the principle for force based on this observation is known as Archimedes principle. It states as follows: a body immersed into a liquid loses weight by an amount equal to the weight of the liquid displaced. Archimedes principle is often stated as follows: when a body is immersed into a liquid, an upward thrust equal to the weight of the liquid displaced. In the fourth flotation, some bodies get immersed into water, such as and the others have. Some bodies, even of the same weight those six float in the water. Law of flotation: a body will float if the weight of the body is equal to the weight of the liquid displaced. If the weight of the immersed body is more than the weight of the water displaced, the body will sink. Now we come to the procedure. Take the selected circular blocks. That is, the volume is for 100 cubic centimeters. Hence, it with the force of a spring balanced with the help of thread. Take an overflow can completely filled with water. Start lowering the metallic blocks, still attached with the springs balance, into the waters of overflow cans.
this is weight when it is immersed into the water, because due to the upthrust force called buoyant force.
Place a waters collecting graduated beakers below the overflow outlets of the cans, and it is to collect the overflow waters due to the immersing the block.
The weight of the circular block should be equal to the liquid displaced, but we didn't get the calculation, so it's not equal. There's no water, then the weight of this graduated beaker is 0.
notes the loss of weight of the body as it gradually immerses into the water, still completely immersed into the waters. Also notes the volume of the display waters by noting the readings of the levels of waters in the gravity text cylinders or beakers. Records your observations. So you will have the observation.
Going to the observation. Volume of a metallic block is equal to the 100 cubic centimeters as written is the procedures. Volume of the batters when totally immersed into the batters is for readings of graduates, cylinders or beaker. Note it would be equal to 100 cubic centimeters. Weight of the batters displays is for 100 grams because batters weighs 1 gram.
So how do we prove that? That when the block is not immersed into the water, it's just in the air, its weight is 200 gram, not 250. It was a mistake that it's 200 gram. So when it's fully immersed into the water, it loses weight by 100 gram. So weight of the body in the air minus the weight of the body that is fully immersed into the water. That is 200 minus 100 gram is equal to 100 gram. Therefore, the weight of water displaced is equal to 100 gram.
Now we come to the friction. And the threads are three of them. This explanation. In inference, or we can say conclusions, the data obtained in the experiments confirms Archimedes' principles. It proves that when a body is partly or completely immersed into the water, it loses weight. The maximum loss in weight of the body is when it is completely immersed into the waters. When a body is partly or completely immersed into the waters, a loss in weight of the body is equal weight of the water displayed by body, is also equals buoyancy force exerted by waters. Volume of the waters display is equal volume of the body immersed into the waters.